Show by the principle of mathematical induction that for all n belonging to the set of natural numbers, the following equation is true. Okay, let us begin. Now first what we'll do, we're going to consider a statement. So let P of n be the statement. Let P of n be the statement, and this particular statement is going to be given by, we have statement given by P of n such that we'll take the equation and we have 1 cube plus 2 cube going all the way up to n cube. That's equals to n times n plus 1 whole divided by 2 squared. Now this is the sum of the cubes of first n natural number, and its sum gives us n times n plus 1 over 2 whole squared. We have to show that this particular statement is true. So let's name this as statement number 1. Right. Now how do we show that it is true for all natural numbers? So here, if we choose the n value to be equals to 1, so for the first natural number 1, so P of 1 is simply going to be 1 cube. All we have to do is consider the first term, and this is going to be equals to 1 multiplied to 1 plus 1 divided by 2, and then we squared it. Okay, so 1 cube, that's simply 1, and 1 times 1 plus 1 over 2, that's also 1. Squaring it gives us 1, which means that we're getting 1 equals to 1, and it tells us that P of n, this particular statement, is true. This is going to be true for n value equals to 1, or you can say for the first natural number 1, the statement Pn is true. Now to show that it is true for other natural numbers as well, we are going to consider a statement. So we are going to consider, so let's say P of m. Let P of m be a true statement. Now if P of m be true, this simply means that we have P of m such that we have 1 cube plus 2 cube plus going all the way up to m cube. So here we are considering the first m terms. We can think of it like that. So we have 1 cube, 2 cube, we have a sequence 1 cube, 2 cube going all the way up to n cube. Now we have considered here one of the term to be m cube. So that's why we're considering here the first m terms, and this was going to be equals to m times m plus 1, the sum, divided by 2, and we square that. Fine. Now we're considering that this is a true statement. Let's call it number 2. Now using this, we have to show that the next consecutive natural number is also going to make the statement true. Next consecutive will be, we have to show here, to show that P of m plus 1, this particular statement is true as well. So what does it mean when we say that P of m plus 1 is true? So what we'll do, we'll take P of m. So, and using this, we're going to express P of m plus 1 as 1 cube plus 2 cube plus all the way up to m cube plus m plus 1 cube. This is going to be equals to, now we replace this m with m plus 1. We have m plus 1 multiplied to m plus 1. So we have m plus 2 whole divided by 2, and then we square this value. So this is what we need to show. We need to show that this particular statement holds true. Now how do we show that this is true? All we have to do is start from the left hand side of P of m plus 1. So the left hand side we have 1 cube plus 2 cubed going all the way up to m cube plus m plus 1 whole cube. Fine. Now the sum of the cubes of the first m natural number, so we can say the adding up the first term all the way up to the second last term, that's actually m times m plus 1 over 2 whole squared. According to number 2, we have already considered 2 to be a true statement, or we can replace this with m squared times m plus 1 whole squared divided by 4 added to m plus 1 whole cube. Now what we'll do, we're going to combine the two terms. So let's do one thing. Let's take m plus 1 whole squared as the common factor. We're also going to take 1 over 4 as the common factor. So that means we are now left with m squared added to 4 times m plus 1. Fine. So this is going to give us m plus 1 whole squared over 4 multiplied to, so m squared plus 4m plus 4, it's actually m plus 2 whole squared, which is giving us m plus 1 multiplied to m plus 2 divided by 2, and we square this value. Fine. So this is going to be equals to right hand side. Fine. This is the right hand side. So we have successfully showed that this simply means, let's write it down, since the left hand side equals the right hand side, so this simply tells us that the statement P of m plus 1 is true. We have showed that P of m plus 1 is true. Hence, we can say that if P of m plus 1 is true, then P of n becomes true. So P of n is true for all values of n belonging to the set of natural numbers. That means any natural number that we pick, so we picked up m, so any natural number that we pick up, P of n is always going to be a true statement using the principle of mathematical induction.